Hello students, welcome back. Previously we studied some exponential equations, or more precisely speaking, natural exponential equations. These were rather elementary, and these two down here were related to logistic models. Remember those? Now let's go to logarithmic equations, and here I can separate right here. No denominator, and we have some denominators. So first three are going to be easier, and these two will be a bit harder, it seems. Let's begin. Let's begin with copying and pasting. And let's put some space in between. It's hard to read. Okay, we are ready. There you go. Our aim is to put all these together as a single logarithm so that log equals to something, and then we're going to kill it off by taking the exponential. But we have a bit of a problem here, this 1/2, so how do you remove it? Well, solution 1, which I prefer, we have denominator. Yes, 2 here is the denominator, so step 1 is always removing the denominator, so let's go ahead with that. Log of x plus 2 minus 2 log of x is equal to 0. You see, multiply by 2, so you have 2 log of x. Multiply by 2, 2 times 0 is just 0, so no change there. And then, let's take all these together as a single logarithm. How do I do that? Log of x plus 2 minus log of x squared equals to 0. That's the key step here. These two, which I just highlighted in red, go right here. Remove the coefficient like this, and then we are ready to combine them all. So, if I combine them all, what do you get? Log of x plus 2 divided by x squared. So log minus log, so we have division. Okay? So log rule number 3, where are the log rules, excuse me. Log rule number 3 here, and then we use log rule number 2. Okay, let's take this one here. Okay, let's put it right here. So we use number 3 and then number 2. Okay, all right. Next, what do you do? We take the exponential of both the left-hand side and right-hand side. E to the log of equals to e to the 0 power. Exponential and log, of course, cancel each other out. So what happens here? This just comes right back. So x plus 2 over x squared is equal to, what's e to the 0 power? It's 1. And we get this equation. A rational equation, x plus 2 over x squared is equal to 1. But don't panic, this rational equation is nothing different from just standard quadratic equation. Just remove the denominator, and then we get x plus 2 equals to x squared. Okay, what do we have? We have a quadratic equation to solve. Okay, we're up to here, so let's complete the problem. X squared minus x minus 2 is equal to 0, therefore x minus 2, x plus 1 equal to 0. So we get x equal to 2, or x equals to -1, oops, we get these two solutions. This one highlighting in blue, this one highlighting in green. So we have two solutions, right? No, not really. Every time you have to consider extraneous solutions. It may work or it may not. Let's plug in x equals to 2 back here. Is that right? 1/2 log of 2 plus 2, which is 4, and then log of 2 equals to 0. Punch your calculator and work out. It'll turn out to be okay. This turns out to be okay. If you plug in -1, that certainly doesn't work because log of -1 is undefined. So you don't even have to do any kind of computation. As a matter of fact, you're not going to do this kind of computation and check. We're going to check only they make sense. This one doesn't make sense. X equal to -1 does not make sense. So that one fails. Oh, I made it too much. Okay, all right. You can still read through, but you can see this is no longer important. So that doesn't work. X equals to 2. There goes method number 1. Solution number 1. Is this the best solution out there? Solution number 2, let's see. Instead of taking these log 2 together, let's take log of x plus 2 equals to log of x squared. Let's do it this way. Okay, and then we can take exponential of both left-hand side and right-hand side. So e to the log of x plus 2 equals to e to the log of x squared. So after cancellation, we get x plus 2 equals to x squared. As a matter of fact, I don't think anybody will write down this step. Just take the exponential of both sides and you can kill off the log. So this one most students will skip. Well, most students will skip. In that case, I should skip that too. So x plus 2 is equal to x squared. So we bypass that rational equation expression. So x squared minus x minus 2 equals to 0. Okay, and then we had x minus 2, x plus 1 equal to 0. From the first factor, we get x equal to 2. From the second factor, we get x equal to -1. And turned out this is a good solution. And turns out this green is not very good solution. Because if we plug in x equal to -1 to this guy here, log of -1, that fails. Okay, this solution is a bit better than the previous solution, I have to say. By taking these two logarithms together, we got this rational expression and then got it back here. Yeah, it was a bit of overkilling. So the second solution is better. Oh, by the way, there may be some students who may do it directly here. Instead of removing this denominator 2 here, move this to this power directly using the log rule number 3. So log of x plus 2 plus 2 to the 1/2 power minus log of x equals to 0. And we get log of square root of x plus 2 equals to log of x, and so on and so forth. But this is not the method I'd like to recommend, because we have square root expression. So you're going to get a square root equation to solve, a radical equation. It's not impossible, but if you can avoid it, why would you do it this way? So this is not the method I'd like to suggest. We have these two. Standard method is actually this one here, combining log into single logarithm and going from there. But this is a special case that we can flip this to the other side so that we can bypass this rational expression. The second method here is better, but it is a little bit less standard, as you will see in the next problem. What if I have something like this? Right-hand side is not 0. Let's put some space in between. In that case, things are harder, and we'll have to apply some log rules here. Let's see, do we have any coefficient? Nothing in the left-hand side, so we can do this one right away. So log plus log, so we have log of multiplication, log of x minus 3 times x plus 4, and then we have this 3 here, so flip it over to the power. Now, if I kill up this logarithm, both left-hand side and right-hand side, by taking an exponential, this is what I get. Is 2 to the third power. What is 2 to the third power? That's 8. So, we have a quadratic equation. Okay, it's going to be a bit tedious, but what choice do we have? Let's solve it. Let's FOIL out the left-hand side. X squared plus 4x minus 3x minus 12 equals to 8. So in the end, x squared plus x, and then flip it, minus 20 equals to 0. Alright, this is turning out to be okay. X plus 5, x minus 4 equals to 0. So from the first factor, I get x equals to -5. From the second factor, I get x equals to 4. Now, do both of them make sense, or only one of them, or neither? It'll turn out this is good, which I'm highlighting in green, and this one, which I'm highlighting in red, is not going to be very good. Plug in x equal to -5, either to this or that, you get log of negative, so that doesn't work. X equals to 4 is the only solution. What do you think? Compared with the previous problem, was it easier, or was it harder, or about the same? I think it was a bit easier. Previously, we had this x squared to consider, but here I have only coefficient 1, another 1. Log rule number 3 applied only to this guy, so I think this one was a bit easier. And in any case, we have a problem like this, and we have another problem of pretty much the same fashion here. Here, 2 goes up there, and we get 3 to the second power, which is going to be 9. I'll leave you with that problem. Let's stop here.